Hello guys, in this video we would be learning about linked lists. So basically what are linked lists? Linked lists are similar to array lists, but the difference lies between how we are storing array list as well as linked list. So in this video we would be covering this concept of linked lists in Java. So let's get started. So if we want to create a linked list contains two parts. Okay, so the first part, that is this part, is called our information part. Okay, and this part is contains the address of the next node. So combinedly this whole can be termed as a node. Okay, so let's see how it works. For example, we have contained in our information part, we have contained some information. For example, this is a string literal. We can consider is this as class A, okay, in double quotes. And it contains an address of another node, that is 123. Okay, so this is class 2, class 3 as well as class 4. So these all contain some addresses. So these addresses are not contiguous, they are arranged randomly in the memory. Okay, so this 123 points to here. Okay, and this address is of class 2. Here our class 2 resides. Okay, these linked list can be implemented. For example, we have different houses. So there in a locality there are various houses. So in order to go to a particular friend's, family's or relatives house, we need to get their address. Similar concept is of linked list also, there needs to be an address. Okay, so this node here, the starting node, is termed as the head node, whereas this last node is termed as our tail node. Okay, so if it had been C or C++ language, we would have made the use of structure keyword, that is struct node, and we had to write int data, and we can use this pointer to store this variable. But here in Java does not support pointers. So how to use this? So basically, see, this whole can be referred to as a class, that is class node. So it consists in, I am taking the reference of this. So here I am taking string data. This data can be of integer, okay, floating point numbers, etc. So we cannot use pointers, but we can use the concept of references. So every address contains a node, right? 100, 123, 345 and 456 contains a node. So this I am storing this part, this is the next part. Okay, so I'm storing the reference of this part in here. Okay, getting this point? So whenever I call this node using some data, that might be string or integer, so this would initialize this data, as well as next pointer would be null. Why? See, first of all, when there is nothing, when I have no node, I am creating my first node, let us say head node. Okay, so I don't have till now class 2 yet, so this would be initialized to null. Okay, now I would be creating another class, so this class would be class B, and this also would be null because there is no reference or no class associated with it, no pointer reference. But this B would be having some address. So logically, programmatically we would be, instead of this null, we would be pointing or uh, putting here address 1212 of this node. Okay, so this becomes a chain. Okay, like this, and this now B is null. So this is the concept of linked lists. Okay, so basically what is the difference between array list as well as linked list? If you say that both are same, I'll tell you the difference. See, in array there are certain elements, okay, and there are certain addresses. See, this is an integer array, so integer consists of 4 bytes of memory. So if this address, the starting address or the base address of this array is 2000, so rest addresses would be 2004, 3 would be 2008, 4 2010, and 2014, and so on. So if you want to get the address of an array, for example, if we do this array 2, for example, array index starts from 1. Okay, so this is our indexing, means at index 2 we have our value 3. So how to get this? We know we have the base address, so base address is this. Okay, and array at 2 at position 2, and what is the size of integer data type? 4. This gets 2008. Am I correct? So we can get this. Similarly we can get a3, a4, etc. Okay, now linked lists. See, these this is consider this as to be a whole node containing info part and next part. Okay, this also similar with some addresses. Okay, so how they are related? They are related via their addresses. See, after 100 it is not 104, it is 200. After that it is 300. Automatically these are not predefined. Okay, so in this way there are the links to this. Okay, if we don't want this, so we can directly have a link to this also, or we can have a direct link to this also. In this way linked list works. So basically, why to use linked lists when we have array, or why to do such type of complex coding when we can use arrays or array lists? So see, in linked list, insertion and deletion is faster, because say for example, if we want to add a element at a location, at location 1. Okay, so what you have to do? You have to shift all these elements one position to their right. Okay, and then thereafter you can add that element. So say you have, this list consists of 10, 100, 1000, 1 lakh, 1 lakh element. It consists of 1 lakh elements. So it is difficult, it becomes a hectic process to shift every element to its right position. Okay, but in linked list what is there? We would be creating a node, for example this node, at any random address. Okay, and just we have to, for example, we have to put this node at index 1. So this is, for example, our head node. So we just need to update this node reference to this. We don't have to change anything else. We have to update this reference to here, and then this reference to the next. Since in Java there is the concept of doubly linked lists, so we can store the address of previous as well as next pointer in a single node. Okay, but linked lists, there are some advantages also. For example, to find an element in linked list, it takes more time. For example, we want this, so this is 1, 2, 3, 4 and 5. Okay, so in order to reach at this position, we don't have a method like this, because this is doing in linear time. But here we have to start from our head node and keep traversing till this node, because we don't have any alternative way. We have to traverse only from our starting node. So this is a disadvantage of linked list, that in order to search, or in order to find a particular element, it takes more amount of time. Okay, so here are some methods of linked list, such as add. So simply first check this, add element e. So this method adds the specified element to the end of this list, whereas this add method would be inserting your element at a particular index. Okay, and similarly this add all, this method inserts all the elements of the specified collection into this list starting at the specified position. Similarly, add all method, add all method consists of this single parameter. So in this it would be adding at a particular index, whereas it would be adding at the end of this list. Clear, it removes all the elements of the array list or linked list. Clone element. See, basically, what is this? Array list and linked list extends the list interface. Okay, so the methods that are provided in the list interface would be similar to that of our array list as well as our linked list, but difference lies between their internal implementation. One's internal implementation is array, another's is linked list. So now we would be moving on to our practical part. So guys, I have made a class for you, that is class linked list. Okay, so here I would be using making a list interface and using new linked list, because this list interface is an interface, so it does not have implementation. So the classes that would be implementing this interface would be having their. So I have imported util.star because list interface is present in a java.util package. So linked list dot add method 12. Similarly, I would be adding some more elements. Okay, 2 and 222. So in order to print this, we can write this. Okay, so since we have understood some methods of linked list, so I would be doing linked list dot add. Since I would be adding at a particular index, so I would be adding at index 1 and my new element would be 456. Okay, so now if I print my linked list, what would it print? See, it would be printing at index 1 I have 456 now, and each element has been shifted if it would be an array, but this is linked list, so just a reference is changing. Okay, as well as uh, we can also use methods like linked list dot contains. So okay, it would return a boolean value. So if I would be checking that if this contains, so it is true, whereas if I write this, so it would be false. Okay, so this is how your linked list works. Another example, uh, I would be using here of mm, I would be using here string lists. So I would be adding string data type to it. So I would be adding some place some. So Dhaka, Erika. Oops, I have to change this also. That's why it is giving me an error. So um, mm, let's say China. Okay, and if I print this string list, okay, so it would be in this fashion. But if I want to sort these. So we have a very good method in our linked list or in our collection interface, that is collections dot sort this string list. So it would be sorting in your O of n long in time. So if you do this, so now it is in your sorted fashion. I hope you understood this concept of linked lists. So in the next video we would be implementing our own linked list class as well as doing certain programming related questions. Till then, have a nice day. Thank you.